Alright, peace family, it's none other than your brother Professor Ace, AfricanCreationEnergy.com, doing this video to respond to an inquiry that I received. So it basically goes like this. Modern scientists use scientific tools to acquire scientific knowledge. For example, the telescope, the microscope, the Large Hadron Collider, etc. If ancient Africans or any ancient indigenous culture had scientific knowledge that they expressed through mythology, what tools did they use to acquire that knowledge? For example, the Big Bang, Sirius B, etc. In the absence of any tools, it seems as though they were just using their imagination to make up explanations and just happened to get lucky that there are some coincidental parallels between the ancient philosophies and mythologies to modern science. So first of all, that is a great question. And this is going to be a deep conversation, and it's going to touch on a variety of topics that have been debated for thousands of years in the philosophy of mathematics. So while it is true that a lot of modern scientific knowledge was acquired using physical scientific tools, what if I told you that the tool most frequently used in science was not a physical tool, but an abstract tool? So have you heard of dark matter and dark energy? What tool was used by modern scientists to discover dark matter and dark energy? Have you heard of string theory? What tool was used by modern scientists to discover the strings in string theory? Have you ever heard of a wormhole? What tool was used by modern scientists to discover wormholes? Now, I've heard of black holes my whole life, but prior to the year 2017, what tool was used to discover black holes? Prior to the year 2015, what tool was used to discover gravitational waves? Prior to the year 2012, what tool was used to discover the Higgs boson? And prior to the 1920s, the Greeks talked about the atom since 500 BC. What tool was used prior to the 1920s to discover the atom? The answer to all those questions is mathematics. Mathematics was the tool used to discover dark matter, dark energy, the strings in string theory, and wormholes, even though we still have not physically detected those objects with any physical tools yet. And mathematics was the tool used to discover black holes, gravitational waves, the Higgs boson, and the atom prior to those objects ever physically being detected or observed. To understand this point, we have to understand the interplay between math and science, or more specifically, the interplay between pure math and applied math to theoretical physics and experimental physics. Pure math is the study and development of mathematical concepts independent of any practical application outside of the field of mathematics itself. It is mathematics for mathematics' sake. Pure mathematicians take pride in the fact that what they work on has no practical application. The father of pure math is a man by the name of George Boole, who Boolean algebra is named after. He thought at the time that the concepts he was developing in Boolean algebra would never have any practical application in the real world. Eventually, those concepts would be able to be applied to computer science. Another pure mathematician was a man by the name of G.H. Hardy. He worked in number theory and thought that his work would never have a practical application. However, years later, after he died, an application for his work was found in the field of genetics. Now, applied math is the practical application and use of mathematics in different fields. In particular, when mathematics is applied to the field of physics, it is called theoretical physics. Albert Einstein is perhaps the most well-known and most famous theoretical physicist, or you could call him an applied mathematician. So my question is, what tools did Albert Einstein use to make his discovery? Albert Einstein was not using any physical tools. He wasn't using telescopes. He wasn't using microscopes. The tool that Albert Einstein used as a theoretical physicist was mathematics. Albert Einstein used mathematics to make discoveries, and he relied upon the work of experimental physicists, people who use physical tools to confirm the things that he was able to discover using the abstract tool of mathematics. One of the famous experimental physicists who was able to verify Einstein's discovery was a man by the name of Arthur Eddington. So understanding that interplay between science and math, what we've observed over time is that sometimes science leads in discovery, meaning the empirical leads, meaning we discover things using physical tools, and sometimes math leads. Sometimes we're able to discover things using abstract tools, the abstract tools of mathematics, before we're ever able to discover them using physical tools. An example of mathematics leading science or mathematics leading physics was the development of imaginary numbers in infinite dimensional spaces. Those were concepts that at the time they were developed, they were thought to have no practical application. But years later, we would be able to apply the use of imaginary numbers in the field of electronics and apply the use of multidimensional spaces in the field of string theory, right? So those were two examples where the abstract tools were developed prior to having any physical thing to map it to. And then there are instances where we make physical observations and we don't have the abstract tools to describe them. So we have to develop new abstract tools. So an example of that is calculus. Calculus was developed because it was needed to describe things physically that we were not able to describe mathematically. Another example is superstring theory, right? Out of the field of superstring theory, we had to develop new types of mathematics. And as of today, there are more mathematical objects than there are natural phenomena to map them to. This is why in the book, The Science of Sciences and the Science in Sciences, which discusses the scientific and mathematical or empirical and rational method, I depict it as a cyclic and interconnected diagram because I understood and recognized the interplay between science and math. So now that we know that the most prevalent tool used by modern scientists is not a physical tool, but rather an abstract tool in the form of mathematics, we have to ask the question, well, what is mathematics? The etymology of the word mathematics comes from the Greek mathematic technique, which literally means technology or tool for learning. So this definition of mathematics is taken from Wikipedia. It says that mathematics is an area of knowledge that includes such topics as numbers, formulas, and related structures, shapes and the spaces in which they are contained, and quantities and their changes. Most mathematical activity involves the use of pure reason to discover or prove the properties of abstract objects, which consist of either abstractions from nature or, in modern mathematics, entities that are stipulated with certain properties called axioms. A mathematical proof consists of a succession of applications of some deductive rules to already known results, including previously proved theorems, axioms, and some basic properties that are considered as true starting points of the theory under consideration. So from the definition, in order to do math, you have to use and apply reason and deductive rules. And deductive rules come from logic. So math requires the use of logic and reason, in particular, deductive reasoning. So to put it very simply, mathematics is logic and reason. In my video called The 9 Types of Reason, I discuss several types of reason used in science and mathematics, namely inductive reasoning, which is used to conceptualize generalizations. It is possible for the conclusions arrived at through inductive reasoning to be true or false. If the premises of an inductive reasoning argument are true, then it is probable that the conclusion is true. Abductive reason, which is used to develop explanatory causes. The conclusions of abductive reasoning arguments must be plausible, but are not uniquely the only explanation, and thus contain some degree of uncertainty. And deductive reason, which is used to make specific predictions. Deductive reasoning has predictive power, and mathematics has predictive power because mathematics is deductive reasoning. The conclusions of deductive reasoning arguments are guaranteed to be true if the premises are true. Inductive reasoning, abductive reasoning, and deductive reasoning occur in a cycle in scientific thinking. So now that we know that at its core, mathematics is logic and reason, now we're getting to the question, well, what is myth? What is mythology? So, first of all, let me state that there are 4 basic theories of myth. Those theories are 1, the rational myth. These are myths that were created to explain natural phenomena. 2, the functional myth. The functional myth is created to bond community and create a type of social control. 3, the structural myth. These are myths that are patterned after the human mind and human nature, and why you find some similarity between different myths in different cultures all over the world. And number 4, the psychological myth. These are myths that are based on human emotion and used to manage the unconsciousness. All right. So in the theory of mythology, of the 4 types of myths, the specific myths that I'm talking about that are used to explain natural phenomenon are called the rational myth. So not all myths were created to explain natural phenomenon, but those myths that do attempt to explain natural phenomenon, they are the rational myths. Those are the ones that basically serve as primitive scientific theories, right? Rational myths, it's in the name rational, with those rational myths which seeks to explain nature, they are also based on reason, in particular, inductive reasoning. Again, inductive reasoning is the type of reasoning that allows you to create conceptual generalizations. Rational myths also contain abductive reasoning or explanatory reasoning, again, because they're created for the purpose of explaining. And lastly, rational myths also contain analogical reasoning. Analogical reasoning is a specific category of inductive reasoning which relies upon an analogy, a comparison between two things that highlights the aspects in which the things are thought to be similar. Analogical reasoning by way of inductive reasoning is the form of reason that creates metaphors, similes, allegories, parallels, mythology, and symbolism. There's a famous anthropologist called Sir James Frazer who also saw the rational myth as a primitive science, right? So the dynamic between myth and math was expressed as the mythos and the logos to the ancient Greeks, which was used to describe the transition in ancient Greek thought from the stories of the gods and goddesses and heroes, the mythos, to the gradual development of rational philosophy and logic, the logos. So what have we covered so far? We've covered so far that mathematics is the tool that is most frequently used by modern scientists to make scientific discoveries, that mathematics is basically reason, in particular deductive reasoning, and that mythology is also basically reason, in particular inductive reasoning, abductive reasoning, and analogical reasoning, right? So let's ask this next question. Where does myth come from? Clearly, we understand that human beings make up or invent myths. And in the case of the rational myth, we use reason to encode symbolic abstractions into explanations about nature. So when it comes to the Dogon mythology about the star Sirius, right, we can deconstruct their mythology to see what type of reason they use to arrive at their conclusions, right? Sirius is the brightest star in the sky. As the brightest star in the sky, they probably said, well, since that's the brightest one, maybe there's more than one star there, right? Maybe there's more than one star there that's making it bright, right? That is a conclusion that you arrive at through inductive reasoning. Part of the Dogon myth also says that if you observe the star Sirius, again, with naked eye observation, if you observe the star for a period of 50 years, there's a point where the star is very, very bright, right? And then there's a point where the star, over that 50-year period, where it starts to twinkle, right? And in their mythology, they say that when Sirius B, with the star that they call the Digitaria, when it's closest to Sirius, that's when the star is the brightest. And when Sirius B is furthest away from Sirius A, that's when it starts to twinkle, right? So again, we can look at what they say in their mythology to deconstruct the reasoning they use to come to their conclusion. Okay, it's the brightest star in the sky, so maybe there's more than one star there. We observe it over a period of time of 50 years. At one point in time, it shines very bright. At another point in time, it starts twinkling. Well, maybe at the point in time where it's the brightest, that's when the two stars are closest together. And maybe at the point in time where it starts twinkling, that's when the other star is further away, right? So we can deconstruct the mythology to figure out what type of reasoning they use to come to their conclusion. Now, there were other portions of the Dogon mythology about the star Sirius that were incorrect, right? They also said that that they thought that there was a third star there, right? And that was supposed to be Sirius A, Sirius B, and Sirius E. So in the Dogon mythology, they actually thought that there were 3 stars there. But our modern science has not been able to confirm the third star. So their mythology was wrong about that. And that's what we would expect, right? So we don't have to conclude anything supernatural. We don't have to conclude that somebody lied about their mythology. We would expect that portions of the mythology, portions of the inductive reasoning argument that they used to come to their conclusion, portions of it were right and portions of it were wrong. And that's what you get out of inductive reasoning, right? The other thing that they said in their mythology was that the Nomo came from an exoplanet orbiting Sirius. Now let's just stop for a minute and just appreciate the fact that they were able to think of a planet orbiting a star, right? We didn't actually have evidence of planets orbiting stars until recently, right? So to even have that thought is actually groundbreaking. To even have the thought about an exoplanet in the ancient mythology is actually profound by itself, right? But then the part that they got wrong, or that we have not been able to verify, that any exoplanet orbits the star Sirius A or Sirius B, right? And they say that it's actually unlikely for there to be a exoplanet orbiting a star system like that, a binary star system like that, right? When it comes to the Egyptian and Dogon cosmologies that have parallels to the Big Bang, we can deconstruct the mythology to figure out what type of reasoning they use to come to those conclusions also, right? Things start small and get big, right? Yeah. Plants grow from seeds. Plants start as a small seed and they grow to a big plant. They grow to a big tree. Animals get born from small eggs. They come out as small eggs and they grow to big animals, right? So maybe everything in the universe also started off as something small and it grew to be a big universe, right? We can deconstruct the mythology to figure out what type of reasoning they use to come to their conclusion. And the analogical reasoning is a portion of the mythology, right? Because in both the Egyptian and the Dogon and the Congo cosmologies that have parallel to the Big Bang, they make reference to things like seeds and eggs, things starting off as something small like a seed or an egg and getting bigger, right? So we know that human beings create mythology. We know that human beings use reason to create mythology. So now this is the question. This is the big debate portion of this topic in this video. We know that both math and myth are created using reason. We know where mythology comes from. So where does mathematics come from? Mathematics is the most prevalent tool used by scientists to make discoveries. Where does it come from? That's the big debate. And there are two sides of this argument. There are people who say that mathematics was invented, meaning human beings create math. And there are people who say that mathematics was discovered, meaning that we're able to discover mathematical principles and mathematical concepts. If you say that mathematics is invented, right, then essentially you're basically saying the same thing. You have the same argument that you had against mythology, right? You're saying that the most prevalent tool used by modern scientists to make discoveries is an abstract tool that we invented and created ourselves. And that's the same thing as mythology. It's an abstract tool that human beings created to explain the natural phenomenon. In the philosophy of mathematics, there's several schools of thought that support the idea that mathematics was invented, right? One school of thought is called Formalism. That basically says that we create the rules and laws and assumptions of mathematics to follow, right? If you've ever heard the analogy of mathematics to a language, well, since languages are invented, then mathematics is also invented. Another school of thought in the argument that mathematics is an invention of human beings is called mathematical fictionalism. This school of thought basically says that math is a useful fiction, like a metaphor or world-oriented make-believe. It's basically a myth that everybody believes in, right? So a good example they say is like, say for example, they say that LeBron James averages 27.1 points per game. Well, nobody can actually score 0.1 points in a game, right? So the idea that somebody can average 27.1 points per game, this is part of that mathematical fictionalism, right? They say that you don't need to know mathematics in order to shoot a basketball in a hoop, but you can use mathematics to write an equation to describe how to shoot a basketball into a hoop. Another school of thought that says that mathematics is a invention of the human mind is called Intuitionism. This school of thought basically says that mathematics is purely the result of the constructive mental activity of humans rather than the discovery of fundamental principles claimed to exist in objective reality. This school of thought also argues that pure math done purely for the sake of mathematics and no practical application to the real world is closer to actually an art than a science. There's no real practical application outside of the fact that you just want to do it. And I wanted to share this quote from Intuitionism from a cognitive linguist called George Lankoff and Rafael Nunez. It basically says that since human beings want to describe, discover, and probe nature, we invent systems that help us do that. And math is able to model natural regularities, but not the exceptions, in a universe which is not inherently mathematic, but are modeled and thus understood by humans through math. If there existed something better than math in explaining and modeling the natural world, we would use that instead. And so that argument basically explains the relationship between myth and math and why, as human beings progress, we went from explaining our natural world through myth to explaining our natural world through math, right? Over time, we realized that myth was not the best way of modeling and understanding our natural world, and that mathematics was better, and so that myth was one day replaced by math as the best method used by scientists. It's possible and even likely that one day human beings will develop another form of abstractions to understand and describe and explain the natural world that's better than mathematics, and that system would replace mathematics as the best abstract tool. Another idea in this argument where if mathematics is invented is very close to mythology, well, people will say that mythology is not completely true. But what if I told you that mathematics is not completely true, right? There's a theorem called Gödel's incompleteness theorem, right? And it's called math's fundamental flaw. Gödel's first incompleteness theorem basically says that any sufficiently expressive mathematic system must be either incomplete or inconsistent. Inconsistent means that it leads to a logical contradiction, which means you can prove anything. So mathematicians trade off incompleteness in order to avoid inconsistency. This means that in mathematics, there are true statements that are impossible to prove. And mathematics will never be complete because there'll always be unprovably true statements. So now we have mathematics, which is developed by reason, mythology, which is developed by reason, mathematics if it is invented by human beings, then it's no different from mythology, which was also invented by human beings. And while mythology has components that are also not true, we have mathematics through Gödel's incompleteness theorem that says that it contains unprovably true statements. So if you say that mathematics is invented, then it's very similar to rational mythology. Last thought, last idea on mathematics being invented. If mathematics is invented, right, then it is unreasonably effective. In 1960, Eugene Wigner, a Nobel Prize winning physicist and mathematician, wrote a paper called The Unreasonable Effectiveness of Mathematics. Wigner's question was simple. Why does mathematics work? Wigner's conclusion was that it's difficult to avoid the impression that a miracle confronts us in the effectiveness of mathematics. When the word miracle is used by scientists and mathematicians, it's a code word for God or the divine. Albert Einstein said that the fact that the universe is even comprehensible is a miracle. In order to avoid the use of the word miracle, which implies the existence of the divine, the naturalist, atheist, and materialist perspective on the conclusion of Wigner's paper is that the unreasonable effectiveness of mathematics is due to a happy coincidence, which means that they just got lucky that mathematics, a human invention, is effective at describing and modeling the natural world. So that's the last thought. So now, if you say that mathematics is invented, right, then that means that the most prevalent scientific tool used for discovery is an abstract tool that was created based on reason, that scientists and mathematicians say that they just got lucky. It's a happy coincidence. It's unreasonably effective at explaining the natural world. That sounds a lot like the sentiment that was expressed in the question that started the whole conversation, that mythology was nothing more than a system that human beings invented that was being used to explain the natural world, that they just happened to get lucky that some of it was right. The other side of the argument, if you say that mathematics was discovered, there's several schools of thought in the philosophy of mathematics on this, right? One school of thought is called mathematical empiricism. That says that we discover mathematical truths through the observation of the real world. Another school of thought is called Constructivism. That basically says that we have to find an empirical example for any mathematical object. Now, there already are counterpoints to those ideas, which we kind of discussed, right? There's more to mathematics than just what is observable in the empirical world, right? Negative numbers, for example, infinity, for example, we'll never be able to observe that empirically. So math is not 100% empirical. Math lacks a purely empirical component. The other counterpoint, if mathematic entities exist, but we cannot detect them by our senses, meaning we cannot detect them empirically, then how do we know we're not just making stuff up, right? If you say that mathematics is discovered, then we're still back to the same question that started the whole conversation. Well, if you say mathematics is discovered, what tools do we use to discover it, right? Another school of thought in the argument for mathematics is discovered is called Logicism, which basically just says that mathematics is logic and reason. That's basically the argument that I've been making during this whole conversation, that at its core, mathematics is nothing more than logic and reason. Another school of thought is called Platonism. Platonism basically says that mathematic entities exist not empirically, but abstractly, and we discover those abstractions. This is the most popular position among mathematicians. The last school of thought is called mathematical realism. Mathematical realism basically says that mathematics is discovered, mathematical objects are real, they exist, and their ontological status is abstract, and that mathematics is so good at describing reality and the natural world because they are part of reality and the natural world, and that they are logic and reason, which are part of the natural world. However, but if this is true, this means that there exists abstract, unknown mathematical objects that just exist that we one day hope to discover. And in the absence of any empirical evidence, this is essentially faith and belief in a quote unquote math god, an abstract object that you believe exists, that you work to discover, that you may not ever really discover. This is really no different than faith and belief. So if you come to the conclusion that mathematics is discovered, that means that the point that underpins that thought and idea is that there exists abstract entities that are used to explain the natural world that you cannot detect empirically, that you believe exist even though we have not necessarily discovered them yet. Abstract entities necessary for explaining the natural world, abstract entities that are essentially the most prevalent tool used to make scientific discoveries that we cannot detect empirically, that we have to have faith exists. I'm sorry, that's deep. So, I don't know. Let's argue in the comments. Is mathematics discovered or is mathematics invented? If you say that mathematics is invented, that means we basically just making up stuff that's not completely true in order to explain our natural world, which is the same argument that people had about using mythology to explain our natural world. If you say that mathematics is discovered, then that means that you have faith that there exist abstract mathematical entities necessary for explaining our natural world, which is the most prevalent tool used in science to make discoveries, that we have to have faith that they exist. That sounds like a math god. So in conclusion, let's wrap this video up. In conclusion, what tool did they use? What tool did ancient indigenous scientists use to make scientific discoveries and encode them in mythology? The answer is they used reason to encode the abstractions and invent explanations about natural phenomena that we call myth, or more specifically rational myth. I'll purposely choose to use the word invent and reason because they denote a more rigorous approach than mere fanciful imagination. And this is similar to modern scientists who use mathematics, which is applied deductive reasoning, to encode abstractions to describe and explain natural phenomena. Is mathematics invented or discovered? If you say math is invented, then literally the same thing that was said about ancient indigenous scientists can be said for modern scientists. That they made something up and they just happened to get lucky. The happy coincidence, the unreasonable effectiveness that it works to explain the natural world. If you say that math is discovered, then that means that you believe in the existence of abstract entities that are discovered by a system that contains unprovably true statements that are then used to explain the natural world. And this sounds a lot like faith and the belief in God, or in particular, a math god. So my closing thoughts. If science is truly to be a human endeavor, that is an endeavor that all human beings and all cultures throughout time have contributed to, then when we discuss the origin and evolution of various topics and concepts in science, we should include in the conversation all attempts by all cultures at explaining and understanding natural phenomena that were derived by logic and reason, but may not have been confirmed until much later by experimental observation, even if those explanatory attempts were encoded using abstractions that we now consider rational myths. This is the type of consideration that is given to Greek philosophy and mythology that is not given to other indigenous cultures' philosophy and mythology, even when scientific experimental observation actually confirm elements of the other indigenous cultures' philosophy and mythology. This promotes a cultural bias and double standard in science, which we should aim to eradicate through inclusivity. This has been Professor Ace of AfricanCreationEnergy.com. Thank you for your time and attention. Peace.